Today we're going to be looking at trigonometry and finding the sides of right-angled triangles. Meet Monsieur Mathematique. He wishes to find out how tall the Eiffel Tower is. However, he can't dangle a tape measure from the top of it, so instead he has to find some other way. He's going to measure the angle from him to the top of the Eiffel Tower. At 20 degrees, he's not quite happy, so he moves closer and remeasures. He finds that the angle between the ground and the top of the Eiffel Tower is now 30 degrees, but he's still not happy, so he moves ever closer, and he finds that the angle is now 45 degrees. He has created an isosceles right-angled triangle, so both sides are the same and both angles are the same. What's perfect about this is if both sides are the same, he can measure the distance from the Eiffel Tower to him, which is 324 meters, and as a result he knows how tall the Eiffel Tower is because it's also the same length of 324 meters with a little subsidence. Monsieur Mathematique used trigonometry to find the height of the Eiffel Tower, and sine, cosine and tangent are our three trigonometric functions that are going to help us. But we need to know how to label triangles first. This obviously is a right angled triangle. There's the right angle. We've also got an angle of 30 degrees. There we are. The hypotenuse is the longest side opposite the right angle. The opposite side is the side opposite the angle used in the calculation, as so. And finally we have the adjacent. This is the side next to our angle used in the calculation. Sine is the main function we're going to look at first. What you'll find on your calculator is a button which is normally labelled as sin. This is the sine function button. Sine is a function that transforms an angle into something else. It transforms it into the sine of that angle. If I were to take the angle of 30 degrees and I processed it through the sine function, I would get 0.5 out. Sine is in fact a ratio between the opposite side of a triangle and its hypotenuse. It can be calculated by dividing the opposite side by the hypotenuse. But what if I don't have an opposite or a hypotenuse? Well, then I turn to cosine, which is the adjacent divided by the hypotenuse, and tangent, which is opposite divided by adjacent. On your calculator, it's listed as cos and tan. From these three ratios, we get our pyramids. These are called so, ka, and toa. So sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. The following trigonometric recipe works for sides and angles. First, label the sides. Second, choose which pyramid to use. Third, cover over what you want to find. 4, substitute in given numbers. And 5, work out an answer. In this example, we're going to find the length of x. We've been given the angle 30 degrees and the hypotenuse of 25. Step 1. You're going to label the sides with opposite, adjacent and hypotenuse. Here's my hypotenuse. Here's the opposite, as it is opposite the angle of 30 degrees. Next, we're going to choose which pyramid to use. We have a choice of so, ka, or toa. And since only the sine pyramid has the opposite and the hypotenuse, that's the one that we're going to be using today. So we get rid of the other two. Then we cover over what you want to find to get the right equation. In our case, we want to find the opposite, so we cover it over, and we're left with the sine of the angle times the hypotenuse. So we're going to use that as our equation. Opposite equals sine times hypotenuse. Then we substitute in our given numbers. So we've got the sine of 30 degrees times the hypotenuse of 25. Sine of 30 is 0.5, and if we multiply that by 25, we get 12.5 centimeters, which is our final answer. Our second example, we've been given a side length of 14, we've been given x to find, and an angle of 27.5. We label our sides with adjacent and opposite, and then we look at our pyramids to decide which one we're going to be using for the equation. We have our three pyramids of Saw, Ka, and Toa. And if you look, the opposite and adjacent only appear together in the tangent pyramid. So if we get rid of the other two, and we cover over what we're looking to find, we find we've got the opposite divided by the tangent of the angle. So if you write this out, we've got the opposite, which is 14, divided by the tangent of 27.5. Now I would advise maintaining full calculator accuracy throughout. However, I will be writing out the first few digits of any longer numbers. So you do the 14 divided by the tan of 27.5, and you get an answer of about 26.8937, etc. Rounded off to 2 decimal places is 26.89 meters. This obviously doesn't look accurate on the diagram, but not all diagrams will be drawn accurately, so beware. How to find the missing angle is something we're going to look at in a further video.